Hi, this is Yuansuo Liu, and in this main lecture, I'm going to go through the problem 2 from my midterm. Let's first restate the problem in my own words. So we are given a unit quaternion like this, the R, and that describes the rotation and frame A to frame B. We also have a point expressed in the B frame like this. The same physical point when written in the A frame is called PA. The problem asks us to, in my own word, I just wrote it down. For the first one, find the rotation axis and angle of this quaternion. And second one, write the P of B as a quaternion. And third one, write the quaternion expression to convert this point from frame A into frame B. And the fourth one is explain that expression using the actual numbers. So finally, we express the result as a vector in the A-frame basis, AZ, AY, and AX. So before solving, I want to quickly review the key concept. A unit quaternion can be written in the form like this. So where theta is the rotation angle and U is unit vector that gives the rotation axis. The most important part is that the scalar part of the quaternion is cosine theta by 2. So on my original midterm, I made a key mistake. I took the scalar part as theta, not the theta by 2. So this is wrong because quaternion always use half the angle. Because of that, my rotation angle was off by a factor of 2. And the rest of the steps were based on the wrong angle. So in this video, I'll correct that and go through the full correct solution. So let's start with the first one. We are given this one, and the vector part is this. I just wrote it down. For the formula, this one, W is equal to cosine theta by 2. We get the full formula like this one. So we can get the theta is 60 degrees, and then next the rotation axis is along the vector part. We normalize vector like this. So U is equal to vector by sine theta by 2. So we already know that sine theta by 2 is equal to sine 30 degrees and is equal to 1 by 2, like this. So U is equal to this, and then we just calculate it. So U is equal to 0 minus 1, 0. This means the rotation axis is the negative y-axis of frame A. So we can write it as this one. So this is the answer. Okay, so for part B, we're given the P of B like this one. So to turn this into the quaternion, we set a scalar part to 0 and use the components as a vector part. So it'll be like this. So we can simplify, right? P of B is equal to 0, 1, 2, 0. This is the answer. Okay, for part C asks for expression that converts this point from B frame to A frame using quaternion math, using sandwich formula, which is this, and then we can write down like this one. P of A is equal to R, P of B, R star. Okay, so here we don't need to expand anything yet. We just show the relationship in terms of R and P of B. That's the answer of part C. So for part B, is expand and simplify using the actual numbers. First, we need to write down the R and its conjugate. So R is equal to 0 minus 1 by 2 0. Okay, and then r star is equal to positive. Okay, and then p of b is equal to 0 1 2 0, right? So now we compute the product. So p of a is equal to r p of b r star. Okay. Okay, so we can calculate like p of a is equal to 0 1 by 2 to like this. So the scalar part is 0 and the vector part is 1 by 2 like this. And for the part the next part, we know that express this as a vector in the A-frame. So equals to ax naught plus a1 and then plus az. Okay, this is the point expressed using the A-frame unit vectors. Okay. Yeah, so this is for the E. Okay, to summarize the quaternion, R is represent a 60-degree rotation about the negative y-axis, and we convert a vector between frame using the sandwich product, which is P of A is equal to R P of B R star, this one. So my main misunderstanding in the exam was forgetting that the quaternion scalar is cosine theta by 2, so I used the wrong angle. Now I correctly use the half angle, and the transformation using R P of B R star matches the expected rotation. That's the end of my mini lecture for problem. Thank you for watching. Okay. I'm Yunshuo Liu, and this is my problem 2, midterm problem 2.